My name is Adrian Almaranes, and my teammates Benjamin Ho, Jason Tran, and Michael Bonga will go over how parts of an electric clipper are made. So first I'll hand it over to Michael to talk about the motor that drives the clippers.
This part is the electric wiring piece which is used to power the hair clippers. We will be focusing on the plastic spool which is made by injection molding. Injection molding is a process that pushes liquefied material into a mold to harden. This process is preferred since the part is required at a fast production rate and has complex components that require dimensional accuracy. In the image on the left, a line can be seen from two molds that were put together. The right image shows the dimensional accuracy is required for this intricate component. Another process that can be utilized is casting, however casting has a slow production rate.
The chassis of the hair clippers were injection molded, and the most obvious sign of this are the marks left behind by ejector pins on both the yellow and black sides of the chassis. Injection molding is the most convenient approach for creating the chassis since it allows high production at a low cost. The Wahl logo appears to be part of the mold, however the number 601 have been laser etched on, judging by the texture. On the outside of the chassis, the words and logos on both sides have been laser etched on since this is the quickest and easiest way to mark plastic. The rubber and metal parts on the outside of the yellow chassis have been attached using adhesive since there are no visible holes on the other side.
The internal razor was most likely stamped out of a long strip of sheet metal. Central cutout and mounting holes were punched out before the stamping of the razor. Looking at the figure, a sign of stamping and punching is the inward curl of the outer edges of the razor and the edges of the central cutout. While it was stamped and punched, some of the material was displaced inwards to create that curled surface. To create the teeth, a cutting tool was probably used after stamping, most likely a grinder with jagged edges to cut all the teeth at once and to keep the teeth as uniform as possible. The surface finish of the outer razor looks identical to the internal razor. The mounting holes have the same inwards indentations, so it's probably created using the same processes as the internal razor. The logo on the front is debossed into the part and was most likely created using chemical etching, which is good for mass-produced components. There's also no displaced material around the logo, so the logo was not pressed into the razor. Alternatively, it could have been machined with a mill, but the letters of the logo have different thicknesses. It is difficult to ascertain because the surface of the logo is hard to see due to oxidation and dirt buildup over time.
The wire winding on the spool creates a magnetic field that drives the motor, and the wire is made from drawing a thicker metal rod into a thin wire. This is the only way that electrical wiring is made. The wire is then wound onto the spool. Springs such as the motor preload spring can be made by two different methods. Hot winding as seen here is typically reserved for thicker diameter coils due to the large amount of energy needed. As shown in this clip, cold winding is used for smaller diameter, easy to form springs. Knowing the diameter of the specific spring being under 3/4 of an inch, it was most likely manufactured with the cold winding method. The green uneven finish signifies that it was also dipped in the corrosion resistant coating.